Hi everyone, we're going to graph the curve whose parametric equations are given and show its orientation and find the rectangular equation of the curve. Sometimes it's best to find this first, which is what we're going to do, because it helps graph it by hand. So basically what I'm going to do here is take this x and solve for t. When I do that, I'm going to square both sides, so I get x squared equals t. And now I'm going to substitute this, my x squared, into this t. So I get y equals x squared to the 3/2. And when you use your power property, you get y equals x cubed. So basically that's our rectangular equation, and you should know what x cubed looks like. The parent function looks like that. And basically when you're plugging in 0 here, you get 0. So basically I have it over here. So when you're plugging in zeros into the t's, so if I have x equals square root of t, and if I have y equals t to the 3/2, basically when I plug in 0, because t has to be greater than or equal to 0, get 0, 0. So we're starting here, and then from there you can just graph that. So it just kind of is the cubic, it's the cubic parent function, and the orientation is to the right. So you're graphing up to the right there. So that's all for that one. And the next one is very similar. I think what I'll do first is solve for y squared here. For y, so I'm going to square both sides. So get y squared equals t, and then plug in this t into that. So we're going to get x equals y squared to the 3/2, so plus 1, don't forget your 1. So we get x equals y cubed plus 1, which basically doesn't help me so much graphing wise. I'm going to go ahead and move that 1 over, and then cube root both sides. And you should know again what the cubic root function looks like that. But in this case, we're shifting over to the right by 1 because of the horizontal shift here, 0. So that's where we're starting. And you can actually look at it here. There's your equation. If I rewrite it, it's y equals cube root of x minus 1. Or we can look at the parametric equations. X equals t to the 3/2 and y equals square root of t. We want t to be greater than or equal to 0. So when I plug in 0, this is plus 1. When I plug in 0, no, which one's plus 1? This is plus 1. All right, so when I plug in 0 here, I'm going to get 1. When I plug in 0 for my y, I get 0. So there's where we're starting, and basically it's that cubic function. And technically it would go down in here. But we're using our restrictions or our parameters here. So we're not using this part. Okay, and the orientation here, since t is greater than or equal to 0, is to the right. Okay, the next one we're going to do is an ellipse. Okay, thank you and have a nice day. Bye-bye.